we will study now Dijkstra's algorithm. And it is nothing but single source shortest path algorithm. Okay, so it is single source shortest path algorithm. It falls under single source shortest path algorithm. Okay, basically it is also it is a minimization problem. And so since it is a minimization problem, we can say that it is basically nothing but an optimization problem. Okay, so what is optimization problem? That either it find the minimal or maximal value. So since it is finding the minimization minimum cost, so we can say that it is nothing but an it falls under optimization problem. And for the optimization problem, one of the best method that we can consider is the greedy method. Okay, so we will solve this Dijkstra's algorithm with the help of greedy method. Now what this greedy method says? Greedy method says that problems can be solved by stages, by taking one step at a time and considering one input at a time to get the optimal solution. Okay, and greedy method has some predefined solution. So with that predefined solution or predefined step, we could find the minimal path. Okay, and this Dijkstra's algorithm maybe it might be directed or in non-directed graph. Okay, so let us write what is your greedy method is. So greedy method says that problems can be solved by stages, by taking one step at a time and considering one input at a time to get optimal solution. Okay, and greedy method has predefined solution. Okay, or predefined step. So we will follow those predefined step and we will find the minimal cost. Okay, so now next thing we will study what is relaxation means. Okay, so first let us draw one directed graph. So first we have to understand directed graph and the cost. So let us say this is node number 1, this is node number 2, and this is node number 3. Okay, so the cost from 1 to 2 is say 2, and from 2 to 4 2 to 3 is say 4. Now when we consider about 1, when I'm staying at node 1, if I say what is the cost of the adjacent node, the cost of the adjacent node is the adjacent node is 2 and the cost is 2. So to go to from 1 to 2 is the cost. Okay, but if I say what is the cost from 1 to 3, from 1, since there is no direct path, so we will consider that the cost from 1 to 3 is nothing but infinity. Okay, so let us say that this 2 node is u and this 3 node, let us say that it is nothing but v. Okay, now from since there is no direct path from 1 to 3, but we can go from 1 to 2 and from 2 to 3, that is via node 2. So if we go from 1 to 3 via node 2, then this cost will be 6, not it will be infinity. But initially, if I say that what is the cost from 1 to 3 without including node 2, it will be obviously infinity because there is no directed path. Okay. Now, so, but considering this 2, we will say it is now 6. Now, now what happened, that this infinity is updated to 6 now. Okay, so so this updation is called nothing but relaxation. Okay, so initially it was infinity, but considering node 2 via node 2, it will now reduce to 6. So this is called nothing but relaxation, or this updation is called relaxation. So we can say that this updation is called relaxation. Okay, and what is the algorithm of relaxation? If distance of, this is d, distance of u, let us consider this is u, so distance of u is 2. So if distance of u plus cost of from u to v, so distance of u and cost of u to v is less than distance of v. Okay, if this condition hold, then we will update this updation problem. So we will update d of v, this d of v is nothing but d of u plus cost of u and v. Okay, so this is the updation problem. Now see, applying this updation problem, what we are getting, initially cost of u is 2, distance of u is 2, cost of u to v is 4, so it is 2 plus 4 is 6, and initially the cost distance the distance of v is infinity, so obviously 6 is less than infinity. Okay, so if this condition is holding, so what will be now du says that it will be du, that is 2 plus this one, this is 4, so it will be, the new du will be 6, so it is now 6. So this is called, this updation is called nothing but relaxation problem. Okay, so hope you understand what we mean by relaxation problem. Now let us do one problem related to this DIJKSTRA'S algorithm. It is very important for the exam purpose. In each year, normally for second year algorithm, third year network, this problem normally used to come. Okay, so just carefully you please understand how I am doing this problem. Okay, you can practice with other problems later. So this is 3, this is now 6, and this is 5. Okay, so let us select, initially I select from node 1, so starting from node 1, so the cost of node 1 is 0. Okay, oh, so I forget this is 2, this is 4, this is 1, this is 7, this is 3 already given, this is 2, this is 1, and this is 5. Okay, so hopefully all the cost is given. Okay, so let us start from the node 1. So from the node 1, what are the adjacent node? It is 2 and 3. Okay, so what is the distance of 2 now? So what is what is this cost of this, or the distance of 2? It is now 2, and this distance is nothing but 4. But what is the distance of 4 now? Because there is no directed path, it will be, according to this, it should be infinity initially. So this is also initially infinity, and this is node distance of 6 is also infinity. Okay, now see, among this 2 and 4, which is minimum? This 2 is minimum, so I select this one. Okay, so I select this one. Now what are the adjacent node of 2? Adjacent node of 2 is 3 and 7 and 4. So what is the cost? See, the cost is, it is 4, but now what will be the cost? The distance, it is 2 plus 1, but that is 3, but 3 is less than 4, so update this 3 from 4 to 3. And let us see this one. This is nothing but 2 plus 7, that is 9, but it is infinity, so it will be now 9. Okay, now see, we have get two new nodes, that is 3 and 4. This 3 and 4, these are the new nodes we are getting. Now what is the minimum, which is the minimum? Obviously this is the minimum, so we will select this 3 now. Okay, so selecting this 3, let us see what are the adjacent node of 3. The adjacent node of 3 is only 5. So now see, what is the cost of this? What is the new du? Okay, distance. So it is 3 plus 3, that is 6. And now initially it was infinity, so we will replace this by 6. Okay, and since there is no adjacent node, so let us consider this one. So this node is selected. Okay, now considering this, what are the adjacent node of 5? It is 4 and 6. Now let us see what is happening over here. Now considering this one, what is the now new distance will of 4? It is 6 plus 2 is 8, but it is 9, so minimum is 8, so we will replace this 9 by 8. And if you consider this one, 6 plus 5 is 11, so it will be updated to now 11. Okay, and now what is the now this 2 is updated. Now let us see among these two which one is minimum. Now this 8 is minimum, this 4 is minimum. So what are the adjacent node of this 4? It is only 6. Now what is the cost of the 6? 8 plus 1, but it is 11, so you can update this to 9. Okay, so this way we have found that this is the minimum cost. Okay, so we will select the smallest path. Let us consider this is vertex and this is the distance of the vertex. So for the 2 it is 2. Now for the 3, vertex 3, the distance is 3. For the vertex 4, the distance is obviously 8. For the vertex 5, it is 6, and for the vertex 6, it is 9. Okay, now let us find what is the complexity. So in each step we can see that there are total n number of nodes. So total so this n is nothing but the number of vertex. Okay, and how many comparison I am checking. Suppose if I consider it as a fully connected graph, that is each edge is connected with each edge. So how many comparison we have to do? If there are n edges, we have to compare with n minus 1. Total number of nodes is n. Okay, so how many comparison? N into n minus 1. Basically it is roughly n square. Okay, so it is roughly basically n square. Okay, so this is the worst case. Obviously it is the worst case, so the time complexity is nothing but this one. So it is theta of n square. So this is the worst case of, or the average case of time complexity of Dijkstra's algorithm. Okay, now this is a way to calculate the smallest path. Okay, now let us consider another problem and we will try to solve it. Okay, so let us consider another problem now. So I draw the problem over here. So this is 1, this is 2, this is another problem. We will solve in the same way, but we will do some extra thing which we will find easy for solving problems in exams. This is 6 and this one is 6. Now see the edge. This one, this one, this one, and 3 to 5, and it is 5 to 3. So it may happen that both cost may not same. This is from 3 to 5 it is 30, but from 5 to 3 it is 35. Okay, so it is 10, it is 45, this one is 50, this one is 10, this one is 15, and this one is also 15. Okay, so let us try to solve this problem. So let us say that we start from this node 1. Okay, so for this what we will do, select vertex, this part. Okay, so starting vertex is 1, say. So select vertex 2, 3, 4, 5 and 6. So starting vertex is 1. So starting vertex is 1. From 1 let us find the what are the cost. Okay, so 1 to 2 it is 50, 1 to 3, okay, 1 to 3 it is 45, 1 to 4 it is 1 to 4 it is 10, 1 to 5 there is no direct path 1 to 5, so initially it is infinity, and 1 to 6 it is also infinity. Now see, among these values, what is the minimum? Minimum is your this number 4 node. So we will select this. So select vertex is now after 1. Now select vertex is now 4. So from 4 we will see what are the where we can go. So obviously 50 we will see that from 4 the only node we can go is to the 5. Okay, so now what is the cost of the vertex 4 is 10. So 10 plus 15 it is nothing but it is 25. Okay, so previously it was infinity, but it is now 25, and all will remain same because there is no change in the cost, and this is also infinity because there is from 4 it is infinity because there is no directed path. Now what is the minimum among these things? Already we have selected this, and apart from this, what is the minimum cost? What is the minimum age or node? It is node number 5. So we select this one. Okay, so minimum is now 5. So now from 5 let us see where we can go and what is the cost. Okay, so from 5 what is the cost? From 5 oh, I think it will be 20. Okay, it is 20. So from 5 I can go to either 3 and to 2. So what is the cost of 5? It is not 25. So 25, see it is 25. So 25 plus 20 it is 45. It is 45, but it was 50 from 1 to 2. So new path is, so new cost is 45. So we will just change it from 50 to 45. And what is the cost of this 3? This is 25 plus 35. That is 25 plus 35, it is 60, but it was 45. So we do not have to change this 3. So now this remaining will be same, and there is no path from 5 to 6 because see the direction. So it is 25 and this is infinity. So these two has been selected already. Let us consider among these two. We will consider, let us say, we will first you can check either you can select this node 2 or node 3. So let us I select this node 2. Okay, so node 2 is selected. Now let us see after selecting the node 2 what are the minimum cost. So node 2 it is 45. So 45 plus 15 it is 60, but it is 10. So no need to change this. 45 plus 10 it is 55, but it is 45. So no updation required for this one. So same thing. So there is no change for 2 for any node. So just I write the same value. Next I choose this node number 3 because this is left. So node number 3. So let us say this is 3. So the cost of it is 45 now. So let us check in any updation could be happen. So 45 plus 30 is 75, but node number 5 is 25. So there is no updation. Okay, so there is no updation. And finally this node number 6 is there. So let us see, but see from 6 you cannot do anything because see that from the direction it is towards here. So in the cost of 6 is infinity, so infinity, suppose this value is suppose 3, it is given that it is 3, so infinity plus 3 is infinity. So cost of 5 will from 6 is infinity, but it was cost of 5 was 25. So no need, so we can discard. We will not consider. We will not update this one. Okay. So final answer will be 45, 45, 10, 25, and infinity. So this is the deduction of the final value, or we can say this way we will also calculate this one. Okay. So this is about regarding the problems of Dijkstra's algorithm. And another important thing for the Dijkstra's algorithm is that, so can it solve the negative edges? Okay. So no, it cannot solve the negative edges, because that is the one disadvantage of Dijkstra's algorithm. So let us say that now 1, 2, 3, and this 4. Okay. This one is 5. This is -3, this is 3, and this is 2. Okay, so this is 0, so starting from 0, this is 3, this is 5. Okay, and now from 1 to 3 it is infinity, but if I consider this path, so it will be 7. Okay, and this is basically -3, so this edge is negative. So next what will happen, 7 plus of -3 is 4, so this is 4, but since 3 is minimum, so we can choose this one. So since this value, so for this case you can update, but there are some problems where this negative negative cost of the edge, where you have to go on updating, and each time you say that you will never find any concrete solution. Okay, so we can say that Dijkstra's algorithm is not solvable, cannot be solved for negative edges. So there are other algorithms apart from Dijkstra's algorithm who can solve this problem for negative edges. Okay, so we will study those algorithms laterwards, but hope you understand this Dijkstra's algorithm. So let us conclude that the Dijkstra's algorithm is nothing but single source shortest path. It is a minimization problem. And minimization problem is nothing but it is an optimization problem, and for the optimization problem we use greedy method, and so we solve this thing by greedy method. And this problem is very much important for but the procedure is very important for the semester exam, so hope we will do other problems. Okay, thank you.